Hey everybody, welcome to week 2 of PS 398. You made it, so now you have some sense about what sort of mechanics to expect from this class. So this is somewhat strange and surreal, it's true, and now that you've been through it once, you have a sense about just what sort of strangeness and surrealness we're talking about. It's going to be a marathon and a sprint at the same time, but I hope that you're getting somewhat convinced anyway that this method of delivering content to you is good. I was going to try to put something more flowery there, and one of the things that's tricky about a class like this, among other things, is just how hard it is to see both the forest and the trees. So that's an idiom that I've never gotten right, not once. I have no idea what can't see the forest for the tree means, but what I mean to say is the following. Each tree that is part of the forest of strategic international relations, this is going to get strained really fast, but every tree in that forest is something worth marveling at. If you go into any woods, every tree is itself a little tiny miracle. And yet, if you zoom out and look at the forest, it is itself a macro miracle. It is an aggregated set of miracles, but it aggregates to more than just the sum of the individual tree miracles. Let's just be done with this. What's going to happen is there are going to be times where you're like, this is just such a blur that at the end of this class, you're going to feel pretty good. And you're like, no shit, fat man. And you're going to feel like you accomplished something, okay? But what I don't want you to lose sight of is that each little week along the way is really important. And the fact that you're blurring your way towards some finish line, the fact that this is going to wind up being a montage in your movie and not just some meaningful scene in your movie, don't lose sight of the fact that we're talking about some really important matters in international relations from the very beginning, okay? So for the next 3 weeks, today, next week, and the week after, we're going to be talking about rationality and how appropriate rationality is as an assumption and as a methodological device in studying international relations from a strategic perspective. That's pretty big, right? There's lots of fights about how appropriate rationality is as a tool in international relations. And it's important that you have some sense about what the heck rationality is. You know, we're not going to spend all of our time talking about the appropriateness of rationality. Like I said, it's going to be these next 3 weeks, but the vestiges of our conversation are going to be all over the rest of this class. We're going to be proceeding as if certain assumptions are satisfied at the global level by every kind of actor that we deal with, be it individuals, human beings, one person, or groups of people, states, institutions, subnational units, firms, actors in international institutions, aliens. All of the different actors are going to be assumed to live up to at least one set of rationality postulates or another. And so I'd be doing you a grave disservice if we just started from, here's some model of international relations, okay? Because you wouldn't realize just how many things are going on underneath the hood, 1. 2, just how controversial some of those things are, and 3, just how cool this part of what's going on underneath the hood is, okay? So this is a really fascinating part of the story. So today's lecture is just going to be about the very basics of rational choice theory. What does it mean for a decision maker, where in particular we're going to be thinking about an individual today. Okay, we'll be talking about you or me. What does it mean for an individual level decision maker to have a preference structure that is rational? What does it mean for them to be consistent enough to be modelable in the models that we'll be using to come? You know, whenever we say that somebody is rational, we're not trying to say, and this is how everybody behaves, all right? As a behavioral assumption, rationality is problematic, just like any other assumption. So whenever somebody makes an assumption about how people behave, they're introducing some problems. And an important part of my task is to show you exactly why we're making the assumptions that we are. It's not because I think, or any other rationalist thinks, that people, states, rebel groups, whatever, act fully rationally. I'm not under any idea that the people that we model actually live up to the tenets that we're going to be talking about today. However, we're going to see that the assumptions that we make, 1, are relatively tolerable, 2, are normatively pleasant, we'll see that throughout the 3 weeks, and 3, they allow us to use some very powerful mathematical tools to greatly simplify our analysis. So if it weren't for the assumptions that we're going to be making today and discussing at length today, if it weren't for the rationality assumptions, if it weren't for that, then it would be very difficult for us to proceed. Not impossible, but very difficult. Any analyst has to make a decision about how many assumptions are they willing to make, how strong of an assumption do they want to make, and how much awesomeness on the back end, how many cool things do they get to do in the models as a result of the assumptions that they made. Okay, this is a tricky part of any scientific enterprise, is figuring out which assumptions do you want to make, how much are you getting out of those assumptions, and does the bang that you get for your assumption buck, is that worth it? And that's something that social scientists bicker about all the time. It's an important thing for us to bicker about. I'm going to try to keep things relatively intuitive and straightforward today. You know, my goal is not for you to come out of these videos with a completely fully formed set of notes that is exactly how to proceed, right? So my goal is to get you to the problem set, and for you to look at the problem set and look at this video and have some rough sense about what's going on, so that then when we meet, you know what to ask. And there might be just some final little adjustments that need to be made, right? Just those little final tweaks. And so today I'd like to keep things relatively intuitive, relatively light, and help you to see that rationality in international relations is an interesting and subtle and nuanced topic worth thinking a little bit about. And that, if you ask me, any student of international relations needs to know something about, because either one might be a rationalist, in which case one ought to know exactly what one is doing, what assumptions is one making, what are the weaknesses of one's enterprise. And then two, for those of us that are not rationalists, what are the charitable criticisms? What are the genuinely true criticisms? What are the not hackish, not glib, not cheap shoddy criticisms to make of the rationalist enterprise? They exist. There's many of them. It's important that if you're going to go on to be some great behavioral scholar or some psychological scholar or some constructivist scholar or some other non-materialist scholar, all these other schools of thought throughout the social sciences, or even if you're just going to become an informed digester of some of these things, you need to know exactly what's happening. And in order for that to happen, I'm going to have to show you some things today. So let's get to it. In the A block, I want to talk about regular preference relations. Preference relations that tell me, for any two alternatives that I have, if I have a Coke and a Pepsi, I need to be able to come up with well-formed statements that I like Coke at least as much as Pepsi, or Pepsi at least as much as Coke. I need to be able to come up with reliable statements, things that are true or false, but not both and not neither. I need to come up with statements of the form, I like one thing at least as much as I like another thing. And we need to talk about what sort of assumptions one makes about the resulting relation. You know, some relation, my weak preference relation tells me whether or not I like one beverage at least as much as another beverage, or one foreign policy attitude at least as much as another foreign policy attitude. So we'll introduce all the primitives of the model, all of the basics of introductory rational choice theory, and then we'll talk about what sort of assumptions one makes in the context of that binary preference relation. You'll see, in the context of that binary preference relation, in order to be able to get our theory off the ground. We will talk about exactly what the axioms are. You will see the axioms. We will not be alluding to the axioms. You will see them, and then you will see them in action. Because in the B block, we're going to talk about utility functions, which is something that you may have seen in some of your other classes. We'll talk about what a utility function is, what it does, and how it relates back to a regular preference relation. This is going to be our working theory of rationality throughout the class. And you're going to see that the assumptions that we make in the A block are going to deliver us some very powerful results in the B block about when we get to use utility functions and when we don't get to use utility functions. And you're like, what do you mean get to use? I mean get to use. You know, a utility function that seems scary to you at first, you're like, oh my God, there's some function. Functions are hard. I saw blobs with dots in it last time. There's all these things happening. You're thinking to yourself, functions are not something that I get to use. Not so. They're actually going to simplify the analysis very greatly, to the point that by the time we get to week 5, 6, 7, something like that, that's going to be part of who you are. Happiness numbers, utility functions are just going to be part of the language of our class together. You and I don't mean this in the abstract, I mean you and me, are going to be able to have meaningful conversations in the context of utility numbers. And those utility numbers are going to convey very particular information about the underlying preference structures of the decision makers in question. Okay? This is going to, this tool, this device, this thing that nobody believes is true, there is no such thing as a utility function. It's not like, oh, you just pinched my utility function parts. Oh, you just pinched my utility function parts. Why am I saying that? That sounds so weird. It's not actually true. It's not true. Utility functions aren't true. What does that even mean? They don't exist. They're tools that we use. And I want to show you exactly when we get to use it. And then in the C block, I'll show you just exactly what sort of assumptions one often makes in the context of utility modeling. However, I want to play with that idea a little bit. I want to show you that things aren't quite as simple as they seem. And you're like, oh, don't worry, I already knew that. You'll see. So in the C block, we'll talk about some applications about what preferences over land might look like. That's sort of an important thing. If you're a state, you're thinking to yourself, boy, it'd be neat if I had some territory, because if I didn't, I'm probably not a state. So what does it mean to have consistent preferences over something like territory? That's going to be something that we talk about throughout the week. So it might seem a little wonky. It might seem a little technical. It might seem a little bit niche-y and a little bit specialisty, okay? But I assure you, this is an important substantive conversation. Even though we're talking about something like the methodology of rational choice theory, underneath this conversation, which appears very abstract, which appears very mathematical, there's going to be equations. But underneath all of that are some really important substantive stories. So try to keep sight of that, try not to get overwhelmed, and just do your best. You're going to do great. Let's get started. So here in the A block, I want to talk about rational choice theory from the traditional point of view, and the traditional point of view operates through a mathematical object called a regular binary preference relation. You're going to be so sparkling at dinner party conversation. People are going to rock up to you and say, hey, what have you learned in college? And you're going to be like, well, I spent a lot of time talking about something called a regular binary preference relation. And people are going to be intimidated. They're going to be dazzled. They're going to be awestruck by just the wonderful, incredibly insightful things that you're able to talk to them when you talk about regular binary preference relations. There's no way I'm aiming this properly. I'm sure that the regular is like way over here. Let me just start over. Regular binary preference relations. Now I'm sure that we covered all our bases. And that sounds super fancy, but it's actually something very simple. And let me introduce it by way of example, and then throughout the problem set and everything will be a little bit more formal and precise, okay? But suppose that I'm an individual. That's a relatively reasonable assumption. So suppose that I'm a decision maker, and I'm faced with trying to figure out what my foreign policy attitudes are. Okay, throughout today's lecture, the motivating example is going to be, hey, what kind of foreign policy attitudes do you have? And just to keep life super simple, let's suppose that there are three possible attitudes about foreign policy, okay? Suppose that I could have hawkish foreign policy preferences, I could have dovish foreign policy preferences, or I could have owlish foreign policy preferences. Hawk, dove, owl. Where the idea is that the hawk is very aggressive and muscular. I don't know why I pointed to my own arm for muscular. There's no muscle there. Can I even kiss it if I try? Only barely, right? So hawkish means aggressive, dovish means more passive and peace-loving, and owlish means some mix of the two. Owls, I'm not sure if you know that, owls are nasty. Owls are like such amazing hunters. They are tough. We think of them as wise, which they are. So this is my set of alternatives. I now have three alternatives that I'm choosing between. You have presented me with some list of alternatives, 1, 2, 3. My job is to figure out how I feel about these things. And you're like, that sounds like a problem for your therapist. But actually, I mean, how would I model what it is to have attitudes over these? And in particular, how would I model what it is to have consistent attitudes over these three things? So here's my set of alternatives. What does it mean for me to have a preference over this? I want to introduce a statement to you, okay? And the statement is going to be about how two of the alternatives work together at any moment in time. Suppose that I wanted to form a sentence of the following form. One alternative is at least as good as another alternative. Is at least as good as. Is at least as good as. Write that down. Is at least as good as. Let's work on that together. Is at least as good as. 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 I haven't even done this in post. This is all just live. Is at least as good as. Is at least as good as. Is at least as good as. In post, it's going to look more like this. Is at least as good as, is at least as good as, is at least as good as, is at least as good as. What if it was RGB separated? Is at least as good as, is at least as good as, is at least as good as. Look, it's my YouTube channel. I'm going to keep myself entertained, okay? This is infinite entertainment here in Urbana, Illinois. So just as an example, suppose that for decision maker me, I'm the decision maker. Suppose that for decision maker I, hawkish foreign policy attitudes are at least as good as dovish foreign policy attitudes, okay? How am I going to write that? I'm going to write hawkish, and then I'm going to use this squiggly greater than or equal to sign. And the squiggly greater than or equal to sign reads, is at least as good as. So I can write hawkish foreign policy attitudes is at least as good as, I'm sure I'm going to not conjugate verbs very well today, dovish foreign policy attitudes. Look, that's just a sentence. That's a sentence. That's either true or false. And when I say it, that means that I think that it's true. So for this decision maker, hawkish foreign policy attitudes are at least as good as dovish foreign policy attitudes. This mere sentence, the sentences of is at least as good as, that single sentence is going to be enough for us to build our entire theory of rational choice. That sentence alone, we're going to build everything that comes after, every single thing, everything that comes after. Week 2 is going to be based on is at least as good as. So is week 3 and week 4 and week 5 and ... and week 14 and week 15. Everything that we talk about is going to have some foundation in the notion of is at least as good as. Now you might be thinking to yourself, this seems an awful lot like greater than or equal to sign. It even looks like greater than or equal to, right? I mean, just a squiggly version of greater than or equal to. And that's true, it is. And the idea is that we want to come up with a ranking of the alternatives using this sign that's just as intuitive as how you use greater than or equal to on the numbers, on counting numbers or real numbers or anything like that. So you're used to the idea of ordering elements of a set. You don't realize it, but every time you say something of the form 2 is greater than or equal to 1, you're announcing something about the order underneath the numbers. The numbers are well ordered. The question is, under what assumptions do I have these preferences well ordered in front of me? What is it about greater than or equal to that I would like to bring to this problem, right? So you're used to greater than or equal to, probably since you were in 3rd or 4th grade. But how do I take all of the intuition from greater than or equal to and bring it to this discrete, substantive problem of figuring out my foreign policy attitudes? Now, I don't want to have to use this squiggly sign every time because it gets very intimidating, okay? And in order for me to show you the concepts of today's lecture, it's going to be easier if we just keep things visual. So whenever I wanted to say that one alternative is at least as good as another alternative, I'm just going to draw an arrow that starts at the first one and ends at the second. So for example, since I just stated that hawkish foreign policy attitudes are at least as good as dovish foreign policy attitudes, I could draw an arrow that goes from the hawk to the dove. If I wanted to say that dovish foreign policy attitudes were also at least as good as hawkish foreign policy attitudes, I could draw an arrow that goes right back. So these arrows they're in a one-to-one relationship with the claims that I'm making anyway. I'm not losing any rigor by focusing on arrows instead of actually writing out the statements. It's the same idea, okay? Now, while we're talking about the arrows, let me introduce 2 other relations that are descendants of the is at least as good as relation, which throughout I'll call the weak preference relation, okay? So whenever I say is at least as good as, we can call that weak preference. Now, I'm going to develop 2 other relations that are children of this. So the first is strict preference. So I'm going to say that one alternative is strictly preferred to another alternative. X is strictly preferred to Y. Hawkish is strictly preferred to dovish. I'm going to say that hawkish is strictly preferred to dovish, or any X is strictly preferred to any other alternative Y. If 2 things are true, I'm going to use an AND. I'm going to use an AND operator. 2 things have to be true. 1, X has to be at least as good as Y. And 2, it cannot be the case that Y is at least as good as X. So for example, suppose that I had hawkish foreign policy attitudes are at least as good as dovish foreign policy attitudes. And suppose that I also knew that it was not the case that dovish foreign policy attitudes were at least as good as hawkish foreign policy attitudes. So I've got a one-way arrow is what I'm saying. There's no reciprocal arrow. In times where there is no reciprocal arrow, that's what strict preference is. So that whenever I say to you, one alternative is strictly preferred to another, is strictly better than another. Whenever I say that, what I mean is it's at least as good, the first alternative is at least as good as the second alternative, and it is not the case that the second alternative is at least as good as the first. Now, you might be thinking to yourself, well, what are we going to call it if it's both? And that's a different thing. We're going to call that indifference. So I will say alternative X is indifferent to alternative Y. It's slightly weird terminology, but this is the usual way of saying it. X is indifferent to Y, or decision maker I is indifferent between alternatives X and Y, if two things are true. One, X is at least as good as Y, and two, Y is at least as good as X. So suppose, for example, now that I added that arrow back, instead of, so I've got hawk is at least as good as dove, and now let's add back dove is at least as good as hawk. So now I've got a two-way arrow. That is what indifference looks like in the context of this picture. So I've got weak preference, that's my very foundational thing. X is at least as good as Y. Hawk is at least as good as dove. From it, I created two other relations, is strictly better than and is indifferent to. And those work just the same way as greater than and equal to, right? So if I say to you 3 is greater than or equal to 3, it turns out the 3 is equal to 3, right? And that's the same thing as we just did with hawk and dove. The idea is to make this as intuitive as it is with the numbers. So now I've got three relations, all of which are born from the same thing. So the core foundational statement is that one foreign policy attitude is at least as good as another foreign policy attitude. So that's my weak preference relation. That's a binary preference relation. Why is it binary? Because you'll notice that I'm actually, even though I'm looking at all the alternatives, the way that I'm constructing the theory is to look at individual comparisons between any two. Now, this weak preference relation, as made manifest in this picture that we're looking at, in this doodle, in this world that we're looking at, I'm going to be able to make three important assumptions, which you'll be able to visualize in the context of this picture. And that visualization is going to be the way that I hope that you'll be able to intuit what it is to be rational. What is it to be consistent? So let me talk about the three axioms of regular preference relations. The first is called reflexiveness. The basic idea of reflexiveness is that if I say to you that one alternative is at least as good as the other, if I say to you is at least as good as, if I've built my entire theory on is at least as good as, then an interesting question is any given alternative at least as good as itself? Right? So if I have hawkish, let's say I'm thinking about hawkish foreign policy attitudes. Are hawkish foreign policy attitudes at least as good as hawkish foreign policy attitudes? Pause the video. Do you think that they should be? Like for you, like if I asked you, hey, let's make it something more manifest. So whatever you're drinking. So let's say you've got cheers. Let's say you've got a Coke or whatever in front of you. Is that Coke at least as good as itself to you? And do you think it's reasonable for me to proceed by saying that it is or is not? Pause the video. Welcome back. If you ask me, I think it's reasonable that the statement is at least as good as. It's reasonable, if you ask me, to force it to be the case that every alternative is at least as good as itself. Otherwise, that statement wouldn't make any sense. So reflexiveness says that for every alternative, in our set of alternatives, for hawk, for dove, for owl, for all three of them, it has to be the case that each alternative is at least as good as itself. So what does that mean in terms of the arrows? It means that I have to draw a little squiggly. I have to make the hawk at least as good as the hawk. I have to make the dove at least as good as the dove. And I have to make the owl at least as good as the owl. So these little squiggly arrows are the manifestation of my reflexiveness assumption. The assumption that the weak preference relation, the statement, is at least as good as. That statement, if you ask me or most people, is nonsensical unless it is true that any given alternative is at least as good as itself. Are you as tall as yourself? Yes. Are you a relative of yourself? Yes. Wait, that's heavy. It depends on whether individuals or genes are the proper unit of analysis. So that's the idea. That statement, as just a beginning check to make sure that things are making sense, we're going to force the sentence is at least as good as to apply for every alternative against itself. So that's reflexiveness. A violation would be one, it could be 1, 2, or 3, but if it weren't the case for all, remember, to negate a for all, I use a there exists. In order to negate a for all, I use a there exists. And so in order for me to negate the idea that for all alternatives, x is at least as good as x, to negate that, what I would say is there exists at least one alternative such that x is not at least as good as itself. So in order for me to break reflexiveness, all I have to do is turn off one of these squiggly arrows. Let's say I took off the dove one. No longer reflexive. Now it's true that if I kept taking them away, it still wouldn't be reflexive, but the thing that broke it was the first one. Okay, it has to be the case that all of them are there. All squiggly arrows have to be there. If they aren't all squiggly arrowed, then it is not reflexive. So that's my first rationality postulate. Okay? 2, completeness. Now, what I just said from reflexiveness is that every alternative has to be at least as good as itself. Completeness takes that one step further and says that for every pair of alternatives, not just an alternative against itself, but now it could be hawk and dove, it could be hawk and owl, it could be dove and owl. Now, for any pair of alternatives, it has to be the case that either x is at least as good as y is at least as good as x, or both. Remember, or means or both in our language. So it has to be the case that x is at least as good as y, or y is at least as good as x. In other words, every pair of alternatives has to be comparable. Now, in the context of the picture, what that means is I can't have any gaps. I can't have any gaps in my foreign policy attitudes. It can't be the case that if you asked me if I prefer owlish foreign policies or dovish foreign policies, I'm not allowed to say I don't know. That's a pretty strong assumption because there are many things that are nuanced. There are many things that are difficult topics, okay? And many people, if you put a gun to their head and said, hey, how do you feel about this? Many people would say, I don't know. However, we're going to proceed on the assumption that decision makers are able to compare every distinct pair of alternatives in their given decision problem. Now look, one thing about international relations that makes it an especially appropriate avenue for rational choice theory is the fact that it is often reasonable to assume that people live up to this. What do I mean by that? So when might you not live up to completeness? I don't know if you've ever voted, but if you go to vote, they tell me, if you go to vote, then one part's like president, senator, maybe your mayor, things where you can easily distinguish the alternatives. Most people, when they go in to vote for president, they have a pretty clear idea about what the two alternatives are, or what any pair of alternatives are. And so they are comparable. They are at least indifferent. They don't say, I don't know. They're at least indifferent. You'll see what I mean in a second. However, as you keep going down the ballot, you might start to get to some offices that you've never heard of. You might start to get to some candidates you've never heard of, from political parties you've never heard of. It isn't the case that you're indifferent between those alternatives. You genuinely don't know. And because you're already at the voting booth, and let's assume that you didn't remote vote or something, because we're at the voting booth, it's not like you can go check Wikipedia. It's not like you can go start looking for things. However, in international relations, where we're talking about leaders deciding, hey, would I rather launch a nuclear weapon or not launch a nuclear weapon? They think that through. They don't not know, right? These are contemplative decision makers capable of comparing any two distinct alternatives. So completeness says I'm not allowed to have any gaps. I'm not allowed to have any gaps. Any two alternatives, there has to be at least one arrow. There could be two. There could be two, but there can't be zero. There has to be one or two arrows between every pair of alternatives. So let's just close this up. So let's suppose for now that hawkish foreign policy attitudes are at least as good as dovish foreign policy attitudes. Let's assume that dovish foreign policy attitudes are at least as good as owlish foreign policy attitudes. And let's assume that hawkish foreign policy attitudes are indifferent to dovish foreign policy attitude, which is to say, on this side of the triangle, let's have two arrows. So I've got one arrow, and then I've got a two-sided arrow here. Okay, so we have now satisfied reflexiveness, and we've satisfied completeness because every pair of alternatives has at least one arrow. Two of them have one arrow, and one of them has two arrows, Reflexiveness, completeness. That's two of our assumptions. These are two of our bedrock rationality assumptions. I should note that I could develop a theory that didn't require completeness. Completeness is a pretty strong requirement for the reasons just discussed. It could well be that a given decision maker isn't able to meaningfully compare two alternatives. And notice that because it's a for all pairs, I could have comparisons between every pair of alternatives except for one, some very obscure or esoteric pair of alternatives that I really don't have anything to relate to, and that single gap would be a violation. 3 is really the assumption that's stirring the drink. The main rationality postulate. Basically, reflexiveness is this sentence well formed? Completeness is something that we're making out of convenience. Where we're really hanging our hat when we talk about rationality is in transitivity. Transitivity is the main consistency requirement, which is what we mean by rationality. Rationality is not about being smart or about doing rational seeming things or not doing irrational seeming things. Scare quotes are very bad. It's not about that. Rationality is about consistency. You have consistent preferences over some set of alternatives. What do I mean by that? I mean transitivity. Transitivity is the primary rationality postulate. Transitivity is the primary rationality postulate. Transitivity is the primary rationality postulate. And it goes like this. Suppose I have 3 alternatives, x, y, and z, where x is at least as good as y, and y is at least as good as z. Okay, so I've got a chain. It goes from x to y and y to z. Suppose I have a chain. Then it must also be true that x is at least as good as z. So every time I have a chain that goes from x to y and y to z, something like that, where one alternative is at least as good as the second, and the second is at least as good as the third, it must also be true that the first is at least as good as the third. So let's go back to our picture. As I've drawn it, do we have a transitive preference relation? Notice, for example, that hawkish foreign policy attitudes are at least as good as dovish foreign policy attitudes. And dovish foreign policy attitudes are at least as good as owlish foreign policy attitudes. Therefore, it must be true that hawkish foreign policy attitudes are at least as good as owlish foreign policy attitudes. And there's an arrow that tells me that that is in fact true. So we've passed one transitivity test. However, that is not the only chain in the picture as we've drawn it. Note also that I have dovish foreign policy attitudes are at least as good as owlish foreign policy attitudes. And owlish foreign policy attitudes are at least as good as hawkish foreign policy attitudes. Therefore, transitivity demands that dovish foreign policy attitudes be at least as good as hawkish foreign policy attitudes. Do you see an arrow there? Because I sure don't. Therefore, as we've drawn it, our current example is not transitive, and therefore this is not rational. This is exactly what irrationality looks like in the context of binary preference relations, is cycles. Little cycles like this. Do you see the cycle? It goes from dove to owl, from owl to hawk, and from hawk to dove. There's a couple of different ways that I could take this picture as we've drawn it and make it rational. You can pause the video and think about a couple of different ways you could do it. 2 come to mind that are especially reasonable. 1, get rid of the arrow between owl that goes from owl to hawk. Now I've got hawk is strictly better than dove, dove is strictly better than owl, and hawk is strictly better than owl. This is the dream, is having all strict preferences, transitive, beautiful, reflexive, complete, gorgeous. This is the dream. Now, this foreign policy decision maker, this person who has foreign policy attitudes, can strictly rank their alternatives. They could tell you that hawk is very best, dove is second best, and owl is third best. Whereas before, they wouldn't have been able to give you a ranking because if you had kept asking them questions, they would have had to contradict themselves eventually. So that's one way I could have fixed this. Here's another. I could have just made them all 2-way arrows, right? So it could be hawk versus dove and different. It could be dove versus owl and different. And it could be hawk versus owl and different. This decision maker thinks they're all the same. They are indifferent between every pair of alternatives. They are indifferent between every pair of alternatives. That isn't irrational. You're allowed to do that. That's not it. This is also a rational preference relation. Rationality has nothing to do with reasonableness. It has nothing to do with reasonableness. It has nothing to do with being a genius. It has nothing to do with making, quote, the right choices. It has nothing to do with that. What rationality means is there's a set of alternatives that you can meaningfully adjudicate, and that there's enough consistency in the choice structure that one could rank the alternatives. There might be ties, there might not be ties, but you could rank them. There's a top and there's a bottom. Gravity only goes one way. No cycles allowed. So far, what have we done? We took a set of alternatives and we came up with 3 axioms for a binary preference relation. Is at least as good as. Is at least as good as. We said, hey, what are some reasonable things to ask of at least as good as? And we saw that there were 3. Reflexiveness. Every alternative is at least as good as itself. If you think that's a bad assumption, then you should send me an email and say, that's the dumbest assumption I've ever seen, and I am prepared to fight you because reflexiveness is a hill that I'm prepared to die on. And you're like, does that mean he'll be quiet for 13 more weeks? 2, completeness. This is the hard one. Every pair of alternatives is comparable, right? For every pair of alternatives, you are no worse than indifferent. You cannot be ambivalent. You cannot not know. You always at least have to be indifferent. Notice, indifference is pretty convenient. All that means is one alternative is at least as good as the other, and the other is at least as good as the first. So indifference, that's totally reasonable. You can have all the indifference that you want to. You can have mass indifference. You can have a decision maker who gives 0 fucks about any of this. Okay? All that matters is that everything is comparable. There are no gaps. That's it. That's probably the strongest of the 3 assumptions that we're making. It's also the one that we're making purely out of convenience. And again, remember, the decision makers that we oftentimes think about in international relations, leaders, or we pretend like countries or people, or rebel groups, or even terrorist organizations. I don't like the word terrorism very much. There was a time when people thought you couldn't model terrorists as if they were rational. And it's like, I don't know why you couldn't do that. But these decision makers care very much about the stakes. This isn't just you're not just answering a poll on your phone that some robocaller, right? They care about the stakes enough that they would at least think through any given pair enough to get to no worse than indifference, maybe strict preference, maybe indifference. And then 3 is where we're really hanging our hat. We're saying that there's consistent choices, transitive weak preference relations. And that's really the most important assumption. Whenever I say rationality, I mean transitivity in one flavor or another. If you tell me that one alternative is at least as good as another, and the second is at least as good as the third, it must be true that I get to reliably infer that the first is at least as good as the third too. No cycles. So that's what a rational preference relation looks like. What does it buy us? Let's talk about that over in the B block. So here in the B block, I want to talk about a somewhat less plausible story. It's called the utility function story. Okay? And the idea goes like this. Suppose that I have some set of alternatives, capital X. For example's sake, let's say that my alternatives are hawkish foreign policy attitudes, dovish foreign policy attitudes, and owlish foreign policy attitudes. You're like, I'm going to drop this class if he's going to keep going like this. I don't want you to drop the class. I really don't. However, I'd be lying to you if I told you that I'm not going to be weird the entire time. So now suppose I don't have any story. Suppose that there's no binary preference relation, there's no is at least as good as, which means that there's nothing to be complete or transitive or reflexive. And so that means that I also don't have strict preference or weak preference. I don't have anything. All I have are these 3 dots. And I need to tell a story about how a decision maker feels about these dots. So I'm going to come up with a different story. And the story goes like this. We have a decision maker and they have something called a utility function. Okay? And the utility function is a device that reads in alternatives and spits out happiness numbers. You're going to get very tired of that sentence, but it's going to happen again and again. A utility function is a device. It reads in alternatives. It takes one blob with dots in it, X, and it spits out elements of another blob with dots in it, the real numbers. So it reads in alternatives and it spits out numbers. So now instead of ding, 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 I've got ding, ding, ding. So I've got hawkish, dovish, and owlish, where these are just the elements. This is a blob with dots in it. And my utility function is a rule that reads in alternatives and spits out numbers. So suppose, as just an introductory example, that hawkish foreign policy attitudes, I get U of hawk equals 2. U of dove equals 1. And U of owl equals 3. So in other words, I go from the hawk dot down to 2. I go from the dove dot down to 1. And I go from the owl dot up to 3. And the idea here is that higher numbers represent more happiness. So I got 3 full happiness points from my owlish foreign policy attitudes. I got 2 happiness points from hawkish foreign policy attitudes. And I got 1 happiness point for dovish attitudes. So this utility function conveys the idea, it conveys that I like one alternative more than another. And the reason that I know that is it has a higher number. That's very convenient. Now look at all the arrows that I don't have to draw. Before, I had this very complicated picture, even with just 3 alternatives, where it's like, and there's cycles, and there's squiggly dots, and maybe some of the arrows are one-sided, and maybe some of them are two-sided, and there's all these possibilities, even just with 3 alternatives. Now, life is way easier. Now, it's just you give me an alternative, and I tell you a number. And that number represents how excited I am about the prospect of that alternative. This is the primary device that is used in political science and all other social sciences. Most papers that are formal theory papers, game theory papers that you read in your other classes, have utility functions. They don't talk about binary preference relations. There's no arrows. There's no doodles. It's assumed that you know about reflexiveness, completeness, and transitivity. And now we can just use this very simple thing called a utility function. That makes life very easy. Because the old way was very cumbersome. It was very, very cumbersome. This is simpler. All right? It's also kind of stupid. There is no part of my brain. And you're like, I don't know that you have a brain. There is no part of my brain that is the utility function part of my brain, as best as I can tell. I've been thinking about it. I just squeeze sometimes and I try to find it. Not there. I found all sorts of other parts of my brain while I was there. You don't realize it, but that was my version of incredibly deep meditation. Right? I just learned a lot about myself. I just learned an awful lot about myself in the last 2 seconds. But one thing I didn't learn about myself was which part of my brain is the utility function part of my brain. Because no part of my brain is the utility function part of my brain. Instead, this is a device. This is a tool. This is a useful fiction. It's simple. It's easy. I could ask you to come up with 5 alternatives that you're choosing between and give 1 of 5, 1 of 4, 1 of 3, 1 of 2, and 1 of 1. Or if there's ties, maybe give 3 of them of 4 or something like that. Numbers. It's very easy to say which ones are greater than or equal to. You can tell me which one is the good one and which one is the bad one. Good ones give you more utility. Bad ones give you less utility. Even though you don't really say, oh God, I have 10 happiness points right now. I feel really great. That doesn't even make any sense, but it's very useful. The question is, how can we ground this utility function in something a little bit more plausible, like how do you compare any 2 pair of alternatives? The idea is that the first story, the story of binary preference relations, the question is, when can we use a utility function to simplify that plausible story of a rational preference relation, one that's complete, transitive, and what's the third one? Completeness. Complete. Adjectives are not the same as nouns. In order for me to link these 2 things, I need to come up with a criterion for what is it for a utility function to tell me something about a binary preference relation. What does it mean when some utility function, which is an easy set of numbers, when do I get to use this? Right? What does it mean for this to be a useful tool? In order to do that, I have to define a concept called representability. Representability goes like this. Here's a definition. So suppose that I have a binary preference relation on some set of alternatives x. Suppose I have a set of alternative x, and I have a binary preference relation on it. So suppose I have hawk dove owl, and I've got the set of arrows, where each of these arrows is at least as good as. The question is, under what conditions does a utility function convey the same information in a simpler way? When does the utility function convey the same information? Let me try to put a finer point on it. When does the utility function equivalent? When are the rankings in the utility function equivalent to the rankings in the binary preference relation? When is U of owl equals 3 a meaningful way for you to summarize all the information in this doodle? So here's the definition. You give me a set of alternatives, x, and you give me a preference relation on it. Call it squiggly greater than or equal to sign. We say that some utility function, u, represents the binary preference relation if, and I'll put this in words before I put it on the screen. The idea here is that every time that x is at least as good as y in the doodle, it has to be true that the utility of x is greater than or equal to the utility of y, which is to say, we want to take the order function, we want to take the order inherent in the binary preference relation and make sure that that order is preserved in the utility function. Okay? So that's actually not that hard. So what we want to say is x is at least as good as y. For any two alternatives, x is at least as good as y if and only if u of x is at least as high as u of y. Notice that, so here I've got the squiggly greater than or equal to sign, and here I've got the regular greater than or equal to sign. Why? These are alternatives. These are numbers. That's what the utility function bought me. The utility function bought me the ability to take talking about alternatives and take that conversation and turn it into having a conversation about numbers, which are easy. That's why I use a utility function. I want a representable preference relation. I want a preference relation where I know that there exists a utility function that does this for me. Because if this is true, if x is at least as good as y, if and only if u of x is at least as high as u of y, if Coke is at least as good as Pepsi, if and only if the utility that I get from Coke is at least as high as the utility that I get from Pepsi, alternatives numbers, that means that I can use the set of numbers and it conveys all of the meaningful information about the rankings that I had in my binary preference relation. It simplifies the process by giving me a set of numbers that are easy to keep track of. So I want to know under what conditions does a binary preference relation have a utility function representation, because then I'll never have to draw another doodle again. Well, you say that, but the next 3 weeks we'll talk about that a little bit more. But in broad brushstrokes, we can proceed using only utility functions if we can talk about under what conditions does this binary preference relation have a utility function representation. When can I take alternatives and convert them into numbers in an order-preserving way? How do I preserve the inherent ranking structure? And here's the result. Here's a result for you. Consider some finite set of alternatives x and consider some binary preference relation on it. Okay, so hawk, dove, owl, and my attitudes about them. So don't get too scared. This is fine. So it turns out that there exists a utility representation for that if and only if it's reflexive, complete, and transitive. So in other words, I can use a utility function if and only if I have a rational preference relation, a regular preference relation, reflexive, complete, and transitive. They're the same exact thing. Being able to use a utility function is exactly equivalent to having a binary preference relation underneath that is reflexive, complete, and transitive. They're the same thing, if and only if. So that's a huge deal, because it means that the assumptions that we made are exactly enough, no more, no less, to deliver the exact same thing as being able to proceed with the utility function. And every time moving forward that we use a utility function, which is going to be most of the time, every time we move forward where an alternative is turned into a number, and the higher the number, the more utility you get, every time we engage in that exercise, which is going to happen so much that you don't even notice it anymore, we're saying that is exactly equivalent to the decision maker that we're trying to model has binary preferences over the alternatives that satisfy completeness, reflexiveness, and transitivity. They're the same exact thing. Let's talk about why you need all three. So just to show you why especially transitivity is important, suppose that I had a binary preference relation that was not transitive. Let it be complete and let it be reflexive, but let's say it wasn't transitive. Just to make life simple, let's say that hawk is strictly better than dove, dove is strictly better than owl, and owl is strictly better than hawk. So I've got a cycle. You see it? Now let's suppose that I was trying to assign utility numbers to these alternatives in a way that represented this preference. Suppose I tried to represent this preference with a utility number. So let's just start from hawk. Notice that hawk is strictly better than dove. Therefore, I'll give Hawk a 3 and I'll give Dove a 2. I'm just choosing numbers randomly. The only thing that I need is for the Hawk number to be strictly greater than the Dove number. The Hawk number has to be strictly greater than, because Hawk is strictly preferred to Dove. Okay, that's the whole point. So I do that. Now I'm here at Dove, and I know that Dove is strictly better than Owl, right? Well, since Dove is strictly better than Owl, I've got a 2 at Dove. Let's turn Owl, it has to be lower, so let's give Owl 1. So let's say that U of Owl equals 1. Now I've got U of Hawk equals 3, U of Dove equals 2, and U of Owl equals 1. Notice, however, that I need it to be the case that the utility of Owl is strictly higher than the utility of Hawk, because I've got Owl is strictly better than Hawk, and that isn't true. I can't do it. There's no way for me to take 1 and make it strictly higher than 3. I just broke it. All of the ordering that you're used to in the numbers is exactly manifest in this doodle. This cycle is what never happens in the numbers. Now, let's say that it had been, let's go back to our nice transitive example. Let's suppose that Hawk was strictly better than Dove, Dove was strictly better than Owl, and Hawk was strictly better than Owl. Now I can go 3, 2, 1, super simple. I just give Hawk 3, that's strictly higher than Dove, 2, and they're both strictly higher than Owl, 1. No problem. If I have a reflexive, complete, and transitive relation, the act of putting rankings on these things is very straightforward. Note also, while we're talking about rational preference relations, suppose that we had talked about the rational preference relation where the decision maker in question happens to be indifferent over all 3 alternatives, which is to say, Hawk is at least as good as Dove, and Dove is at least as good as Hawk. Dove is at least as good as Owl, and Owl is at least as good as Dove. Hawk is at least as good as Owl, and Owl is at least as good as Hawk. And everything is at least as good as itself. So now I've got every arrow I could possibly want, and then some. Notice that this is reflexive. Every alternative has a squiggly arrow. It's complete. Every pair of alternatives has at least 1 arrow. And in fact, every pair of alternatives in this example has 2 arrows. And it's transitive, because every time there's a chain of 2 arrows, the required 3rd arrow is there as well, because all arrows are there. It's relatively trivial to check that particular problem. You can pause the video if you need to. So let's just say I gave them all the same utility number. Let's say that's a 1, that's a 1, that's a 1. Now, X is at least as good as Y if and only if the utility of X is at least as high as the utility of Y. Well, notice that Hawk is at least as good as Dove, and so we need the utility of Hawk to be greater than or equal to the utility of Dove, which it is. They're all the same. You could repeat that exercise for all 6 comparisons that you could make in this drawing. Okay? This utility function of they all have the same exact number represents the completely indifferent preference relation. So it turns out, and I won't bother proving this for you, although it's not very hard, that transitivity, completeness, and reflexiveness are exactly all that we need to be able to use a utility function. And every time we use a utility function, we are essentially stating that there exists some binary preference relation that is complete, transitive, and reflexive. They are exactly the same story when we tell them just the right way. These assumptions that we make are there not just because we think they're reasonable, which, if you ask me, I think that they oftentimes are. Reflexiveness is almost always reasonable. Completeness, sometimes yes and sometimes no. And transitivity, I think for most decision makers that are relevant for international relations, transitivity is reasonable. More importantly, if you ask some person on the street their preferences over something, and because they aren't thinking, they happen to violate transitivity. Suppose that you mention this to them. You're like, did you notice that you have this weird little cycle thing happening? And say you didn't say weird. Then they would correct themselves. Most people would correct themselves, it turns out. If they happen to violate transitivity and you bring it up to them, they say, oh, good point, thanks for telling me. There's some normative appeal to transitivity. There's something inside of us that very naturally wants to rank things in a consistent way. You don't have to know the name of transitivity. You don't have to have seen the definition of transitivity. You don't have to know exactly what it looks like in a picture to have felt it. These are our pleas for understanding. Our mathematical models are not our statements of how we think the world is. It is our attempt to try to pin down what it looks like is happening to us. Now, none of us believes there's a utility function out there, but the result that I just showed you, that representability, if and only if rational, that point demonstrates that we can use the simpler tool that's easy on us without having to make any stronger assumptions or weaker about the decision makers in question. That's what science is supposed to look like. That's what a consistent, unified, principled enterprise for understanding international relations is supposed to look like. I issued axioms, and now I'm going to learn what they buy me. Now, over in the C block, I want to demonstrate just how tricky it is to use utility functions if you're not making some further assumptions. I want to demonstrate that actually deeper assumptions are oftentimes very convenient, although they are not necessarily tied to our story. So I'm looking forward to showing you some interesting wrinkles there. See you in a second. So the way I want to get into this is I want to show you how difficult it is to try to animate a particular substantive problem using rational choice theory without making some further assumptions. However, I also want to highlight that the assumptions that we oftentimes make they go one step further. They are in fact parts of the modeling enterprise rather than part of the rational choice enterprise. Okay? So I want to proceed by assuming that there's a unit interval. Suppose that there's a unit interval that goes from 0 to 1, okay, and that I'm the leader of a country. Suppose that I'm the leader of a country, and I'm trying to form my preferences over how much of this territory I have. This is all land. Suppose that this is all land. Now notice that land, it turns out, is not just one simple interval like this, okay? I'm not sure if you've noticed, but there's many dimensions around us. There's 4 dimensions that we experience if you include time, right? And the world itself is not flat, it's a sphere. You can model space a lot of different ways. You can pause the video and think about all of that if you want to right now, but let me show you the usual way that territory might get discussed in a rational choice model. So the idea is that this is all the available territory for me to have preferences over. However, a given alternative is going to be some subset of this, some subset of the interval, okay? So just to demonstrate that, suppose that we were considering the interval, the subset of the interval where I have nothing. Suppose the empty set was one of the possibilities. The empty set is a subset of every set, including 0, 1. So there's one of the possibilities. One subset of 0, 1 is the empty set. So there's a possibility. Boy, I hope that's my least favorite alternative because I don't want no land if I'm the leader of a country. I want some land. So suppose instead that I looked at some version where I had all the land between 0 and 1/2. Here's another subset. Okay? That's a subset with bandwidth 1/2. Like notice that it's 1/2 wide. So here's one possibility. This is look, I'm just holding my whole kingdom in my fingers like this. Just get creative. Just get creative. It's okay. Just try to see it. So maybe the whole world, maybe my whole country is contained in 0, 1/2. That's a possibility. Notice that there were all sorts of ways for me to have this much land. So there's one that goes from 0 to 1/2. There's one that goes from 1/4 to 3/4. There's one that goes from 1/2 to 1. There's all sorts of ways for me to have exactly this much territory. Okay? In fact, there's an infinite number of those. The one that goes from 0 to 1/2, the one that goes from 1/2 to 1, and everything in between. Now look, I could have pinched it. Let's say I only had a quarter. Let's say that I only had a quarter of the available territory. It could be that I go from 0 to 1/4. It could be that I go from 1/4 to 1/2, from 1/2 to 3/4, from 3/4 to 1. I could, or everywhere in between. There's an infinite number of ways for me to have 1/4 of the available territory. And in fact, for every possible caliper size, it could be this much, it could be the whole thing. But for every possible caliper size, there's an alternative. And you can imagine that means different things. So suppose that in this territory that I've just drawn, So for all this territory, suppose that there was a gold mine at 3/4. There's a big gold mine at 3/4. It's right there. You see it? It's right there. Now think about my 1/2 bandwidth. The 0 to 1/2 doesn't have the gold mine in it. Let me try and let's say I can't. There's one that goes from 1/8 to 5/8. Do you see it? It goes from 1/8 to 5/8. That doesn't have the gold mine in it either. However, once I have the one that's 1/2 wide and starts at 1/4, then just the very boundary has the gold mine. And in fact, anything past that will contain the gold mine. So here's an interesting question. What would it mean to have consistent preferences over all of these possible 1/2 bandwidth ones? Right? Maybe all of the territory is the same, except whether or not you get the gold mine. Okay? So let's say that I get a utility of 1/2 for having a territory size of 1/2, and let's say that I get an extra little bump if I have the gold mine. Let's say I get a 1-point bump. So in other words, from 0 to 1/2, that gets me 1/2 of a happiness point because I have 1/2 and I don't have the gold mine. 1/8 to 5/8, that gets me 1/2 of a happiness point because I have 1/2, I have territory of size 1/2 and I don't have the gold mine. However, for all of the other ones, once I get to the 3/4, once I get to 1/4, now I'm guaranteed to have the gold mine, and so all of those give me 3/2 of a happiness point. You can work out for yourself that the associated preference relation for that, for any two, let's say that the set of all alternatives was the set of all subsets, all connected subsets of 0, 1 that had a measure of 1/2. 1/2 of the territory. My hand is getting sore from having 1/2. Oh, it's hard to be the king. So for every one of these, I'm indifferent between this one and this one. I'm indifferent between this one and this one. I'm indifferent between this one and this one. And then once I get the gold mine, I'm no longer indifferent. However, I'm indifferent between all of the ones that include the gold mine. Right? So that's a perfectly rational preference relation. I can use a utility function to pin that down. The 1/2, 3/2 thing. Notice that there's no rule that says that my territory has to all be connected. Notice that every one, no matter what the bandwidth was, right? It was this, it was this, it was this, it was this. For every bandwidth, it's still one connected thing, right? It's still one connected thing. But when Pakistan first achieved its independence, there was East Pakistan and West Pakistan, right? There was, and so what is now Pakistan was West Pakistan, and what is now Bangladesh was East Pakistan. Right? They were not connected. They weren't connected. So what if I had 2/4? So compare, I have 1/2 versus I have 2/4. It's tricky, right? That's really tricky. Because then what I would do is maybe I would put 1/4 wherever I'd make sure that my first quarter hit the gold mine. And then maybe I would try to figure out where the other quarter of my state would go. So then what should be my preferences over having 1/4 where the gold mine is and then 1/4 elsewhere and they're not connected versus a half that doesn't have the gold mine versus a half that has it. So now I've got 3 different kinds of alternatives. Connected, no gold mine. Connected, gold mine. Disconnected, gold mine. Now I've got to really think hard about what consistent preferences are going to look like in this world, right? So maybe to model that, I'll say there's a little bit of disutility that happens if you have a disconnected state. It turns out that disconnected states are hard to manage. So if a state doesn't have one contiguous space, it's more likely to have a civil war, for example. You can imagine that it gets way more difficult for you to extract revenues if you need to tax. If you can't say credibly, and if you don't pay your taxes, I'm going to ride over to your place and start extracting them from you physically, well, that's harder to do when you're not connected. What if India, which happened to fall in between the two Pakistans at the time, what if India said, no, you're not allowed to come through here? Now you got to take a boat all the way around, or you got to go through the mountains. It's a hard time. It's very difficult to extract rent if you don't have a connected territory. If you don't have a physical way to get there. There's all sorts of reasons that you might prefer to have one connected territory versus two disconnected territories, right? And you're like, boy, Indonesia seems hard. Yeah. So maybe in order to model that, maybe I'll say that there's some disutility. Let's say that if I'm not connected, I lose a half a happiness point. Okay. So now that means all of my connected without, that's a half a happiness point because I don't have the gold mine, but I'm connected. For my connected with the gold mine, that's 3/2 of a happiness point. That's great. And for my disconnected with the gold mine, that means I have 1/2 of the territory. That's great. The gold mine gets me up to 3/2, but then the lack of being connected means I lose another half a point. But right now, all that I'm doing is modeling. I am not talking about the assumptions of my theory. I'm talking about what is the proper way for me, an analyst, to model this interesting problem of what kind of territory, what does a state want to control, how does connectedness play into it, and how do resources play into it. Now look, all that I'm doing is talking about territory that is homogeneous, save for one single resource, and having it be one piece or two. It could have been 3, 4, 5, 10. I could have all the different subsets that I want to. And it could have been all sorts of different dimensions. Right? Now look, the usual way of modeling in international relations is to ignore all this and just to assume that more territory is good and that all territory is connected. So in most of the models that we'll be discussing in this class, the utility function associated with how much territory you have is exactly how much territory do you have. So I'm just going to draw a border. Let's say that here's Washington, D.C., and here's Ottawa. That's in Canada. That's a different country. It's north of America. See, I know real things about the world. And what I'm going to do is I'm going to put a boundary. I'm just going to say, suppose there's a border that falls in between the United States and Canada. And maybe it's very close to Washington, and maybe it's very close to Canada. Now here's the idea. I'm going to call that border X. It lives in 0, 1, little x. Do you see it? So if X is a small number, then America has very little territory and Canada has a lot. And if X is a very big number, then vice versa. Okay? I'm going to assume away all of the gold mines and all of the disconnected possibilities. Here's the easiest possible way to put a utility function on something like territory. Or any other issue that seemed multidimensional, but actually can be boiled down in a simple utility way. And I'm going to say that America's utility for any given x, u sub u of x equals x. Which is to say, if I'm at 1/2, then I get 1/2. If I'm at 3/4, I get 3/4. If I'm at 1/4, I get 1/4. I get happier and happier as I get more and more territory. That makes sense. And I'm going to say that Canada's utility for x is 1 minus x. They like it when x is small. They want more and more territory. The idea here is that if you have all of the territory, you get 1 happiness point. If you have none of the territory, you get 0 happiness points. If you have half the territory, you get half of the happiness points, and so on. That's a simple utility representation where we took a very complicated set of alternatives, the set of all subsets of 0, 1, which is so big that it's difficult for me to describe to you. I can talk about this in lecture if you want to. The set of all subsets of 0, 1 is, I could cry thinking about it. It's huge. It's cumbersome. It's terrifying. It's terrifying. You can't even define probability over that. So what we do is we make modeling assumptions, not rationality assumptions. We had rationality on the gold mine. We don't make rationality assumptions. We make modeling choices to say, if I don't care about gold mines in connected spaces, then why the hell am I modeling gold mines in connected spaces? If all I care about is more territory good, which is oftentimes the case, and we'll talk more precisely about when that would be the case in 4 weeks. If all we are at is a point where more territory good, then I can issue a monotonicity assumption. That's a further assumption. That's a stronger assumption. Where I say all of the subsets that I care about are the connected subsets, and more in your connected subset is preferred to less in your connected subset. That has nothing to do with rationality and everything to do with what do we think are the relevant features of the world that we want to include in any given model. Is it gold mines and connectedness? Or is it more territory good because you're bargaining with some other country? This is our enterprise, combining assumptions with modeling choices, tasteful modeling choices, intelligent modeling choices, insightful modeling choices, in the hopes of telling stories that mean something, conveying meaning in a principled way. I hope that this whets your appetite because this is the world we're going to be living in. The rationality world is the gravity. It is the set of physics. However, that set of physics does not stop us from being able to come up with 2 or 3 or a Google different cool stories to tell in that world with its associated set of physics. So today's lecture was about physics. The next 13 are going to be about what we're going to do there. So what do we talk about today? Well, we talked about rationality. We talked about what is it for an individual to have rational, consistent, regular preferences over a set of alternatives. And we saw that what we mean by that in particular is consistent enough to be similar to how we rank the numbers. The idea is that a rational decision maker is somebody that looks at alternatives the same way that your calculator looks at numbers in terms of how they're ordered. There can't be any inconsistencies. It has to be the case that any given alternative is at least as good as itself, the same way that 3 is equal to 3, 5 is equal to 5. It has to be the case that any 2 pair of alternatives are comparable. One is at least as good as the other, or the other is at least as good as the first. The same way that for any given numbers, either one is greater than or equal to the other, or the second is greater than or equal to the first. One of the following 2 things is true, or both. 4 is greater than or equal to 3, and 3 is greater than or equal to 4. Which one's true and which one's false? 4 is greater than or equal to 3. We could have allowed or both. 3 is greater than or equal to 3, and 3 is greater than or equal to 3. For this you're paying. That's equal. Finally, there has to be transitivity. If you know that one alternative is at least as good as another, and the second is at least as good as the third, as some third, then it has to be the case that the first is at least as good as the third. The same way that 3 is greater than or equal to 2, and 2 is greater than or equal to 1, has to give you a consistent inference that 3 is greater than or equal to 1, which it is. So what we're saying is, a rational decision maker is somebody whose squiggly is at least as good as relation is similar in terms of its structure to greater than or equal to on the numbers. And once we're talking about that, then we might as well talk about numbers. Well, how do we get from alternatives to numbers? Through utility functions. Now, I've said the word story a lot today, and I don't know. If you're anything like I was when I was starting to learn some of this stuff, it's interesting when words like story come up, because science is not supposed to be about stories, right? Stories sounds an awful lot like what you read. Like, it sounds folksy almost, right? So I like books with like folk tales in them. I think folk tales are cool. But folk tales don't seem very sciencey to me, right? There's all sorts of wonderful stories, and different cultures have different stories, right? So there's Greek mythology, there's Roman mythology, there's different mythologies associated with each of the major world religions. There's Norse mythology. There's all sorts of different Native American mythologies. There's trickster tales from many of the indigenous peoples that live throughout North and South America. There's all sorts of different stories, and that doesn't seem like science, right? And yet I've said story to you many times. And it's with this important notion of storytelling in mind that I'd like to conclude with a provocative thought. Game theoretic modeling, like any other mathematical modeling, in the social sciences at least, and maybe in others. I can't claim, I don't know the first thing about physics, okay? You saw me with drag last week. I don't know anything about anything, and you're like, we noticed. But at least in the social sciences, game theoretic modeling and other mathematical modeling does not appear to me to be a matter of getting things right the same way that it is for a physicist. When I talk about a utility function, I'm talking about something that doesn't exist. There doesn't exist a utility function part of your brain. If I'm an economist, demand functions, supply functions, those are convenient analytic tools that an economist uses to try to pin down something that they can't really explain succinctly. In other words, there's a simplification going on in the hopes of telling a consistent story that gives you some punchline that matters. In that sense, mathematical models in the social sciences are like fables. They are indeed stories. They make incredibly strong assumptions about what's happening. They say, this is the set of physics that's going to be relevant for all of the worlds I'm going to talk about. Right? This is my universe. This is my Marvel universe. This is my DC universe. This is my game theoretic universe. Okay? The universe sets the physics. I'm going to use rational choice theory, which means I'm going to have decision makers who have preference relations that are reflexive, complete, and transitive. And then once I'm there, I'm going to start telling stories. And the point of the stories, mathematical models that live within a given class of models, like game theoretic models, the point of these fables is to convey meaning. So let's talk about the fox and the grapes. So once upon a time, there was a fox, and the fox was walking down the road. And she looked, and next to the road, there was a very high vine that had some grapes on it. It went very, very high. It had got unique sun angle. And so consequently, at the top of this vine was the most beautiful, tantalizing bunch of grapes that the fox had ever seen. The fox looked at these grapes and was struck by how delicious they looked. And suddenly she noticed that she was starving, and she wanted those grapes real bad. So she goes over to the vine, and she starts to try to climb it. She starts to jump, she starts to climb, she starts to scratch. No matter how hard she works, literally like Tantalus, she can't reach the grapes that are above her. Those grapes are way too high. There's no way that she's going to get there. Nevertheless, they are beautiful looking grapes, and it's worth trying. And so for an hour, she jumps, she claws, she climbs, she tries everything in her power, and she can't get to the grapes. Eventually, there comes a point where her legs are aching. I don't know what foxes have. Her hinds are aching, and the lactic acid is pumping through her muscles. She can feel just how little oxygen is in her blood. She's been working too hard. Okay, she can't go any further. She's done trying for the grapes. And so finally, as she resigns herself to the fact that she's not going to get this most delicious looking bunch of grapes that she's ever seen in her entire life, as she walks away, disappointed and skulking, she mumbles to herself, those grapes were probably sour anyway. That's a beautiful story, and you probably heard it. If you haven't, you're probably going to remember it. We say sour grapes all the time, and when we say sour grapes, we're referring to that particular fable. It's a part of our language. It's part of the Western canon, in a sense, in as much as something like that exists. Now look, there's a lot of assumptions that went into this story. One, foxes really don't talk to themselves all that much. I'm not sure if you've noticed, but foxes don't talk. I've tried. I walk up to foxes all the time. I'm like, hey, how you doing? What's up? You want to learn some game theory? And they look at me like a fox does, which is to say they sort of hollow-eyed. There's nothing in there. They're intelligent animals. They're sly like foxes, but they don't know how to talk to themselves. They can't say to themselves, oh, I'm going to get me some grapes, or those grapes were sour anyway. So in fact, the punchline, the fact that sour grapes are the thing that we get out of this story, the fact that she mumbled to herself, those grapes were probably sour anyway, that didn't happen because foxes can't say sour grapes. Moreover, grapes are poisonous to foxes. Did you know that? Grapes are poisonous to foxes. She never would have gone after those grapes, and if she did, she would have died. This has nothing to do with how foxes actually interact with grapes. This story sucks, right? No, this story is awesome. Why is the story awesome? Because you're going to remember it. It conveys an important message to you that oftentimes people who don't get something that they thought that they wanted very much, after the fact tell themselves that they didn't really want it. That fable, that very memorable image of a fox climbing and scratching and jumping and striving and failing, that fable can't get out of your mind. And every time you see something else in the real world, a human, every time you see somebody do that, you can say to them, boy, that seems like sour grapes. Which is to say, the fable is a device that you use to relate different states of affairs to one another. I can have a sour grapes phenomenon, and you can have one, And they're similar to one another in the sense that they are both relatable to our wonderful device of the fox and the grapes. The analytic structure of fables helps us to relate different real-world scenarios to one another. Even though foxes don't eat grapes, even though foxes don't mumble to themselves. The realism of the fable doesn't stop it from serving its purpose. So when I tell you stories in this class, I'm going to have a bunch of them. There's a lot of stories in international relations. There's a compendium of international relations fables. If you look at the literature, the strategic rationalist literature in international relations, all that it is a collection of fables, all of which start with imagine a decision maker with a utility function over some set of alternatives. We don't do that because we think that there are actual decision makers with actual utility functions, just the same way that I don't think that there's actual foxes with actual grapes. We did it because we're going to use this to try to relate different states of affairs to one another. This is the point of a model. So whenever somebody says to you, or whenever you're talking with one of your friends or one of your professors or something, and they say, but people aren't really rational. Yeah, that's true. Foxes don't really eat grapes, but that wasn't the point. Now, there's another thing that one might say in response to this, which is, is there a book of fables? And the idea is that literature really is the book of fables. And so one remarkable thing is to convey to you that the book of fables is not yet finished. Every day, there are professors and grad students or other people, analysts that work at the State Department or whatever. There's all sorts of different people who try to write new fables every day. Fables about how states interact with one another using the set of physics inherent in the rationalist paradigm. They do this not because they think that there is indeed rationality all over the world, but because they're just part of this tradition of telling stories a particular way. Just the same way that wasn't really any one storyteller that came up with all the different fables. That was an ongoing process, and so consequently, every culture has its own beautiful book of fables. And so the strategic rationalist paradigm in international relations is no different. Some of those fables are mathematical, some of them aren't. But if you see it that way, that gives so much room. It means that we get to be creative. It means that we get to be makers. One thing that really bothers me about how we teach things to you is that we forget to show you that in the social sciences, a lot of what we're doing is so human. And to think a thought in a principled way, even if it isn't a thought you think is true, just to hold the thought in your mind for a second is one of the noblest things that you can do. Just to play. It seems so scary. It all looks so mathematical. It all looks so abstract. It all looks so sciencey. And it is, but it isn't. And so that's why I teach you rationality this way. I want you to see it as the foundational fable for all of the fables yet to come. And I'm going to show you the state of the art. I'm going to show you where the ending of this current book of fables is. But I don't want you to think that that's actually the back cover. Science proceeds, or at least the social sciences proceed, by continually bickering about what the right stories are, what the useful stories are, and how we're supposed to relate these awful things that happen, and sometimes good things, but mostly the awful things, it seems like. How do we relate these things to one another in a way that allows us to understand our past, to understand our future, and understand our present? I think that once you get a taste for that fable view of this, you're going to realize that there's a lot of opportunity to have a lot of fun and not just see this as problems, as little math puzzles that need to be solved, but rather a gigantic storytelling enterprise that's never going to be finished. Thanks for watching.